What you're looking at is me setting up to calibrate an Interacoustics 608 audiometer. Now that could be a Benson, a Trimetrics, a Monitor, a GSI, Mako, any of these interface units. They all work the same with this calibrator, which is an ACS Model 102 calibration and analysis system. Simply take the patch cords, which I have plugged into the back where the headphones were, into the ACS system where it says audiometry, marked right and left. Now take the headphones, which were previously plugged into the back of the audiometer where the patch cords are, and bring that over and mark it into the where it says headphones, right and left. The reason for me doing this is I just got off the telephone with someone asking about calibrating a pure tone screening audiometer. The type used in school or OSHA compliance testing. They were kind of confused about such a sophisticated task, so I decided to show them just how non-sophisticated and simple it is with an ACS calibration unit. I've plugged in the USB cable into the side of the computer. Now we call that a controller, but it's just a low-end PC, and it comes around plugged into the back of that 608 audiometer where it says USB. Not very complicated so far. Now we've been in this industry for a very long time, and years ago, after Neil Armstrong first stepped onto the moon, we decided that if a computer could do a better job of driving a spaceship to the moon and back than an astronaut could, then why not have it do a better job of calibrating an audiometer than a technician with a sound level meter? About 15 years ago, we computerized the manufacturing calibration analysis system of the Grayson Statler audiometers while they were in Madison, Wisconsin. Now it's still in use, only that we've expanded that into tympanometers, audioacoustic emittance, ABR, any function that a testing device can perform. Other manufacturers have followed. Still, some feel they would rather have a tech with a meter.
Alright, we've got the audiometer connected onto the ACS system. Let me show you how this works. Click on the screen, on the screen with the icon of the ear. It pops up. Now what it's showing on the screen here is the last customer that this program dealt with. And it was Ajax Foundry, and they had a Benson 200 Mini. Well, we can take and put in a new customer and go through all this, but I don't think it's necessary. Let's go back down and cancel that out. You understand that. I'm going to select out a customer. Those customers are going to stay in your database as long as you want them. This screen should be full. I'm going to select out, and we're going to do ACS, the OSCO system. I can select an audiometer that I've already done for this company, but I'm going to select out a new audiometer to show you the selection that we can do. Now I've got subcategories of the group that are in over here, or I can even put a user defined. If we don't have a pattern in our system, you can take and make one up yourself. I'm going to just click on show them all. I can page through these by going to the down arrow key on my computer's keyboard and select through the many audiometers that we've programmed in. Now some of these you probably have never seen before because they're not marketed in the United States, but they're used in the manufacturing of the ACS system is used in the manufacturing of it. Or I can come up here, click on this pull down window, and let's select out one that we are looking for. Well, it's not up over there. We come back over here, and it's an Interacoustics 608, and there it is. If I click on that, it brings it up and propagates the field, and we'll see that we have two little asterisks behind the model number, and this indicates that it's an interfaced audiometer. Now, we have to put in a serial number, and we want to put in for both the headphones and the audiometer. But because it's an interface, if that data is stored in the audiometer, all I have to do is come down here, click on this. It gives me a warning that if it's not firmware version 107 or greater, we can't do the calibration. Well, let's see. It makes a successful interface, and propagates the serial number into that field in the firmware version. Now, if that would have also stored the serial number for the headphones, it would have come in over here, and we think it's important to put that information in at this. It also gives me this option of selecting out different headphones if I want, but I'm going to stick with this TDH39s. Stick this in over here. I don't know what the numbers are. I'm just putting in some information. Now we know it's not inserts are not into this audiometer. We know it certainly doesn't do high frequency. We know that it's a class 3 clinical, and that's because it has something in there. I'll show you at the end of the test. Doesn't do bone conduction, and certainly is not set up for free field, so I'm all set. I'll click on OK. Gives me the option, do I want to use the standard default test to calibrate this audiometer? You're going to use that 99% of the time. This is mostly used in the manufacturing facility. We can edit that test configuration. Again, you're taking control of the spaceship. Leave it alone. Click on OK. Only thing left for us to do, calibrate the audiometer. Click on Calibrate. Gives us some other selections that we can do. We know that it's interfaced because that box is clicked and the program recognized that. Marks out these areas because it's interfaced and we have no control over that. No reason to retest the connection. We've done that already because we've transferred the serial number over. I can set this up and use user control, but again, you're taking over command. Get a little more sophisticated if you want to do that. Go ahead and do it. Leave it in fully controlled. Fully controlled, it knows that you're going to do the headphone test. You're not going to do inserts. You're not going to do high frequency. You're not going to do bone. But here's something. You're going to do the electrical test. Pretty tough for that to be happening if you're just using a sound-level-meter. We know it's not free field. We know it's not a tympanometer, and the system knows it's not ABR. We have the option of just measuring the audiometer only and doing nothing, or we can measure and adjust the audiometer levels, which is, again, the majority of time what you're going to be doing. I'll just simply click on OK and wait for some other instructions. I'm going to take the coupler, bring it over here, and place it onto the right headphone, making sure that it's properly seated. So I click on OK. Guess what? We're in control. The audiometer, the computer has taken charge of this information, and it's going to continue on doing this until it's finished, or until you get some more commands. Now, unfortunately, I think I have to do something here. Unfortunately, we've done this audiometer many times before, and it's all within calibration. Every time we get an ACS system in for service and update and calibration, we go through several tests before we take and send it back to them. I think I'm going to go back in. I'll wait and go on to the left here, and I'll show you how that can be readjusted, because this kind of moves right along. I could have stopped it and changed it and brought it around, but I'll show you that in the left ear. Now here, because this audiometer has all the frequencies starting in at 125, it's going through the full scope of them. I'll speed this up later on so that you don't have to sit here and listen to my boring conversation. And by the way, I hope I'm not getting scored on video proficiency, because if I am, we have a big problem. I'll accept scores on audiometer calibration, but not on video performance. The reason we're doing this on acoustical is because later on you'll see that we're going to do an electrical, and we want to find out if there's a difference between those two outputs. Just about done, and I think what I'll do is going to ask me a question over here, or for some help, because as I said, it doesn't have. Simply following the instructions, we'll take the coupler and bring it over and place it on the left
headphone, and we're all set to continue.
Okay, and we're going to start doing the test. I'm going to go over and kind of rock that headphone off of there a little bit on one of these and see if I can't get it up to something else. Now, we're 4 dB off. It's going to compensate for that 4 dB and recalibrate the audio. Oh, I must have moved the headphone a little bit. Well, it's off 7 dB. It's brought it up to there. So that calibration now is in the system. I'm going to put the headphones back on there, and I'm going to come back. I'm going to click back up here on 250 and tell the audiometer, tell the calibrator to go back and redo those. Which it's done, and it's corrected the mistake that we had in there from before. You see that with 7 dB off, it corrected it. Here's minus 2.2 brought it down to 2/10. I think that's where I've stopped, but it'll give you an idea of what can do, what the system will do. You'll see this later on because we've documented the fact that that audiometer has been out of calibration, and it will show on the calibration sheet because we record both pre and post. Switching over into the left ear, starting it again. Now, I'm sitting over here talking a great deal, and I wonder if I've told you this. If this was a Benson 200 Mini or a monitor or one of the instruments designed strictly just only for industrial application, the frequencies selection out of that, it goes only from 500 to 8,000. So but the computer program knows that. If you have a Benson 200 Mini in here, you're only going to get a selection of doing this procedure to 500, 1,000, 2, 3, 4, 6, and 8. And it will do this complete test procedure. As you can see over here, we've changed the output of that audiometer all the way from turning the intensity level from 70 dB up to 100 and back down into 90. That's the manufacturer's specification. And here we're on to the electrical analysis of it. We're talking about the frequency response, the total harmonic distortion, this off to on signal ratio, the fall time, the rise time, the overshoot, and I guess we've selected out on here not to do the crosstalk at 125. Again, onto the 250. It's going through this. I remember one time a friend of mine asked somebody else how they do the rise and fall on an audiometer and check for overshoot. We had an evasive question for a long time, and finally we said, well, come on, tell us how you do that, because if you've got a better way of doing it than we do it, we'll consider maybe making a change. He said, well, we listened to it. Okay? That's the one that has I got a phone ringing in the background. You're going to have to put up with it a little bit. That's all right. I'll just let this run. I'll go answer the telephone and let the system calibrate the audiometer. I'm running a video. I can't talk to you now. Well, here I am back. That didn't take long. But you see, if you hear that beeping in the background, that simply just tells me that everything is going fine. If the system would have detected something that was out of range or it couldn't cope with or it didn't compute properly, it would have buzzed and shut down. So this is what I'm saying. The computer has full control. It doesn't get tired. It doesn't get bored. It doesn't get late for an appointment. It just does the calibration of your audiometer exactly the way the manufacturer's specification and ANSI certification says it's supposed to be done. There are no shortcuts. There's no okays. There's no lines through a linearity. There's no close enough attitude. So we're just about through with this right ear in linearity. In analysis, electrical analysis. And I believe we're going to go over, we might be going over and doing it in the left ear also. If it does, I'll edit this out and get through this really fast. Well, here we are in linearity, and we're on to the left ear. We start out at 70 dB, went up to the maximum output of the audiometer, which is 70, which is a manufacturer specification again, and start going down in steps of 5 dB. Now, if you want to change the steps that you're using or the intensity, that's fine. Program it into the system. That's what that selection of modifying the test pattern was all about. But it's not according to ANSI standards. Like I said, this is manufacturer's specification. The ACS program was used in the manufacturing of this 608. Now that wasn't all bad going through that left ear, or I think it was the left ear on the electrical test down there. Because I'll tell you what, give me an opportunity. I made a fresh cup of coffee, so get a little caffeine in me, and I'm ready to roll. I might go back and talk all through that thing again. But I think by that time you're going to miss it anyway, because you're all going to be sleeping. Another thing, take a look. See if we're going down to 10 dB. I can go to minus 10 dB if you want to. Try to do that with a sound level meter. Most of the background noise levels and in the linearity of the attenuator done on people with just a sound level meter, they usually will stop at about 20 dB. At least that's what I've seen it coming back in from the field. Maybe not so much in the manufacturing thing because they control the environment. But if you're out in industry or into an environment that's noisy, try testing linearity down to 10 or to 0. See how successful you become. Let me find out what's going on over here because I really don't know myself. Oh, here we are. We're going to do the pulse with test on here. I think it was pulse. We had a big discussion with one of the manufacturers that they were not performing, that did not meet the spec, and we call it, oh, and here's what made this a class 3 clinical audiometer. Now, you didn't even have to know that that warble was in this audiometer, because the computer did. And that's the reason they had a computer flying a spaceship up to the moon rather than some astronaut sitting there with a joystick in control. Again, performed to the manufacturer's specification. And the test sequence is complete. All I have to do then is come back up over here, click on OK, and take a look. If you had anything on this test procedure that had not passed or fell outside the spec, it would appear in here in red. If you hadn't done it, it would show up incomplete. Now, I'm not going to go into the room acoustics and the hand switch check, but those things are in there also. On an industrial grade audiometer, it automatically comes up and forces you to check the hand switch. 99% of the time the audiometer is not working right, watch out, it's the hand switch. But I can edit the notes at this point. If I found out something that I want to talk about, I can come back in over here and add whatever kind of a little note that I want to pass on. This is part of the test procedure, and it's part of the certificate that's printed out. I'll just say OK. I'm going to save the results, and they're in the database. They're going to stay there along with the pertinent information on your calibration data. So if 3 years you want to go back in and reprint that calibration certificate out, it has the microphone, serial number, the date of calibration, everything pertaining to that particular test. If I want to view it now to find out what it is, I can click on it over here. Here's the headphone level. I have that the left ear. If I want to take a look at the right ear, I can come over here. If I want to take and show what it was on pre-adjustment, that was on the left ear. Bet you thought it wasn't going to show up. There it is. If I wanted to see what was going on with the notes, I can come back here and edit them if I'd like to. If I want to view the certificate before it prints, now I have a selection of the items that I want to print on that. Plus, I want to show pre and post levels. Click on OK, and there's your calibration certificate. Now, I think some of this is cut out, and I don't believe there's anything I can do about that right now. But you notice down over here, it does show your pre and post levels. If you need a copy of this certificate, give me a call. Let's see if I can't put my telephone number on the bottom, or drop me an email, Clarence@audiometry.com. Thanks for letting me bore you.